This is the session on, we're basically going to be building an AI agent that's focused on incident investigation. And after I created this title, I realized that, incident investigation is kind of vague, but we're going to be specifically focusing in on investigating incidents that happen inside of a deployed code base or app. So software, and looking at how that might tie in together. Couple of notes. This is an introductory level tutorial, so I'm going to assume that people don't know much. And so if you come in with just a basic level of Python, you'll hopefully be able to kind of keep up and follow along. And yeah, so let's go ahead and get into it. And again, if you are coming in, just make sure you grab the repo, get your API key in Docker, and you'll be good to go. Let's see, let's make sure these slides work. Okay, so just a little bit about me. So I'm from Northern Virginia. I'm currently a Master's of Data Science student here at the University of Virginia. I have a Bachelor's in Applied Mathematics from BYU, and I'm currently an AI engineer at a company called Winning by Design, where I do some agentic work for them. And so I'm excited to share a little bit about what I've learned over the last couple of years about agents with everyone here today. So let's talk a little bit about how this day is going to go. So we're going to start by discussing a little bit about what agents are, why they're useful, why every news article is filled with agents these days. We're going to move into a demo where we take a look at what we're going to be building. I'm going to showcase the final product. We'll then step into the code and do kind of a mix of step 3 and 4 there, where we're going to walk through the code, but then also build together. And then we'll have a small discussion at the end about some of the things we can take away. So let's talk about agents. So take a look at this graph. Interest in AI agents. So this is right from Google Trends. Take a look at that up and to the right, exponential curve, right? 2 years ago, January 1st, 2024, agents weren't even a thing. They weren't even registering on the graph. Like early 2025, they start to become a bigger thing, and then boom, 2026, we are like at the peak interest in AI agents. Everyone's talking about it. Like I said, news articles everywhere are just talking about agents and agentic workflows and Claude. That's all I feel like I hear about. Claude Code and NemoClaw and all these different things. So agents are very clearly important. So what even is an agent? So an agent is really just a system that uses AI, which, when we say AI, today, most people are referring to a large language model that uses the AI reasoning to be able to make decisions and then take actions with given tools. So that's what makes it so much more powerful than just a chat, right? It's actually taking action and getting something done, as opposed to just recommending something or maybe just giving some advice. There are a couple of key parts to agents that I think are good to understand. First of all, there's a trigger. So this is what kicks off the agent. So this could be a wide number of things. It could be something as simple as, you click run. You actually start it off manually. You could have a file drop into something like an S3 bucket and have it start that way. You could have it be on a cron schedule, so it runs every morning for you or something. In our case today, we're going to be looking at metrics pulling from a backend to be able to, and then measuring it against certain thresholds to kick off our agent today. And I'll talk more about that in a second. The second part is the LLM. So this is obviously what makes it so powerful, right? If you don't have a brain, can't reason, it's not going to actually get anything done. So the LLM is by far the most important part, and choosing your LLM is also really important, right? If you have an agent that's focused on making images, I would probably personally put in something like Nano Banana into the agent so it can have the best model of images. Whereas if I'm focusing on a coding agent, I might put in Claude or Claude Opus 4.6 or something. And so again, the LLM is very important. But in my opinion, the most important part of any agent is actually not the LLM, but it's the tools associated with your agent. So the tool calls are what the agent can actually do. And we'll talk a lot more about tools in here in a second. But if you take only one thing away from this entire presentation, I just want everyone to remember that tools are the most important part of an agent. And the stronger The stronger your tools and the more time you spend planning your tool set, the more robust and the more granular and the more powerful your agents become. And then at the very end, the agent might compile some kind of final response and give you some type of deliverable. And then we'll talk more about how it stops a little bit later. So the world is saying a lot about agentic AI. I'll just put up these quotes. Enver Seton, who is an AI expert at Cyclum, said, "You can define agentic AI with one word: proactiveness." And then this guy, Satya Nadella, he's a CEO of some kind of company. He says, "AI agents will become the primary way we interact with computers in the future. They will be able to understand our needs and preferences, and proactively help us with tasks and decision making." So clearly, some of these world leaders are talking a lot about agents, and so we have, we ought to listen, right? Learn a little bit more about them. So let's talk a little bit about what we're going to be building today. So, as I was preparing for this, I built out a small mock e-commerce website. I mean, it's very run of the mill. It basically allows the user to enter in some basic information about, a transaction and click run on the front end. It sends a request to the back end, does some data processing, right? Mock processing that will simulate, and then returns a response. So we have this very simple full stack application that we're going to be using, and that's pre-developed. So that's just something very simple that we're going to be using to then build our agent off of, which will help solve some of the problems. So in addition to coding that basic functionality, I also coded up the ability to inject error types. So you can pick off a certain error type, and then you'll see the error pop up as you transact, and then you can use that to test our agent, right? So the three error types that I've coded in are, number one, a memory leak. So if you're if you're not handling your memory correctly, it's going to start to build up the cache. You're going to see some latency. It's not going to run super fast. And so the way to fix this is really to either clear out your cache, restart your program, right? And then maybe look into your code and find where you could be managing your memory correctly and a little bit more, improved there. Error number two is unhandled errors. So, when this error is enabled, essentially our API will occasionally return a none type, and our app will try to access it, throwing an error, right? So the fix to this bug in our code is to just add an error handling. And then lastly, a 500 level error from our payment processor, such as, if this were Visa or someone who's maybe upstream from our application, and their service is down, what do we do? In our case, we would want to maybe notify the users that the issue is coming from Visa and not from us. We want to notify Visa so that way they actually get a hold of the issue, and then we maybe want to continue to monitor. All of these things, all these different fixes you see here are things we want to consider for our tool set, because those are the actions that we want to take when these issues start happening in our code. So let's talk a little bit more about the trigger and the LLM for our use case. In our backend, we keep track of three different metrics: error rate, latency, and memory. And so I have arbitrarily chosen these thresholds. If any one of those thresholds are triggered, our agent will go ahead and get started and start investigating. Obviously, these are kind of arbitrary for this use case, but it's important to think about. If you're in a hospital and you want a really low error rate, you want basically zero error rate, then you want the thresholds to be incredibly low. So that way, even at the slightest indication of an error, our agent will go ahead and kickstart and get going on fixing whatever the problem is. Whereas if you're in a situation like us, maybe it's an e-commerce website, it's important, but maybe not super important. You can think about how you want to adjust the different thresholds and how much is acceptable to your application. And then we have our LLM. For this use case, we're just going to use any of the three that I've listed here: OpenAI, Claude, or Gemini. I think for this, it's more important that everyone can participate, and so I wanted to allow all the LLMs available. But I do think that as you get into more specific use cases, it is important to make sure you're using the right model for your use case. But we're going to use any one of these three for our application today. So let's talk about the tools. So the tools we're going to be looking at today are number one, getting the metrics. And I think there's something actually really important about this specific tool. So getting the metrics from the backend is a way for the agent to see what the current status is of the runtime of our application. And so I think this is a really important one because as the agents get better, they need ways to verify that what they've done is actually improving the application and not actually hurting it. And so if you give an agent a tool such as get metrics, right, it can constantly check to see how the application's doing and then use that as a way to objectively measure its performance. If it checks the metrics before it starts and the error rate's at like 50%, and then it does a whole bunch of work and then checks again in about a half hour and notices that the error rate's down to 10%, it's done a good job and it's improving. And so it can use that as a way to get down to the bottom and you can set goals for the agent in that way. So I think that tool is really important. We have some other tools such as search logs and get recent logs. Both of those take simple arguments. Search logs, just you pass in a query, you pass in a log level, and then it returns the log. Get recent logs, right? Grabs the last 25 log lines. Read source code. So this is where we attach the source code in our Docker volume, and then the agent can go take a look at the coding file and determine if there's some type of fix, and can actually read through our code, which I think is really insightful, and we'll talk more about how that actually works in a bit. And then we have reset service. This one's important because it actually is a mutating tool. It's actually going to change the state of our application, so we need to be careful with that tool. And then lastly, get health. This is just to make sure that the backend is even on to begin with, right? If it returns anything other than a 200 level request, we want to maybe think about how we want to fix that. Or maybe that's an error in and of itself, right? Application's offline. So these are the tools. And then I'll also just throw this up here. I want to just emphasize how many tools there are to build. I mean, if you can think about it, it can be made into a tool. We just take some of these, right? Send a message, snapshot a page, rank candidates, run Terraform. You can map directions. Really, if you can put it into a Python function, it's a tool, right? And so I feel like that really unlocks, at least when I think about agents and what they're able to do, if you just think about it like a Python function, it unlocks like this huge slew of things you're able to do because, Python's obviously so versatile. And then let's put it all together. So now we have our trigger, we have our LLM, we have our tool calls, and then we have this agentic loop. So the agent will actually loop through. It'll decide if it needs to make a tool call. It'll make the tool call, see what the results were, and then either finish and terminate on its own or keep running depending on how the tool calls went. And so this is what really makes it valuable is this what I like to call scaffolding around the LLM. So that way you can give it the context it needs, the tools it needs to be able to perform its task. Yes. Well, so this is a great point. So can you give me that? Yeah. So do you need to edit the code as well? Yeah. And the truth is absolutely. In a more complex agent, we would absolutely want an edit the agent tool. In this specific case, I decided not to put it in, and that's because obviously when you edit code, you're starting to get into some permissions and security level risks. And obviously, if you take into account the different risks and you account for them all, you can absolutely use a tool like that in a very powerful way. For us today, we're not actually going to dive into that, but it's a great point. And I think that if we were to make this production level today, we'd absolutely want that. And that's the kind of tool that Claude, if anyone's ever used Claude Code, you'll see it run, it reads like 100 lines from a code file, and then it says like edit 100 lines from a code file. It's exactly the same thing that we would want in our application. Maybe even creating a pull request is another great way to do something similar, right? Maybe it's like, going to make some edits and then pull requests. So that way there's a human in the loop for that mutating tool. But yeah, great point. Are there any other questions before we move on? about the basic setup of our agent architecture, about tools, about how this is all tying together.
Why would we code these specific tools when we can just give it access to the terminal? I can do all these through bash terminals.
Well, some things can be done in the terminal. It's true. But also you might want to have even more specific granular tools, or maybe you don't want to give it access to your terminal, right? I mean, it's a pretty big security risk. So, like, for me, I would want it to give it really specific rules, and we'll talk about this at the end. But enforcing the idea of the least privilege, or so you don't ever give the agent access to something that it shouldn't need or have access to, so you avoid the risk of those different security events. But it's a great thing to think about, right?
It also forces it to do things the right way. So, for example, reset service, right? Like, there's many ways to reset service. So if you give it a tool and tell it to use it, then it'll do it the way your Python. That about
Yeah, that's a great point.
Reproducible is another way to
do it. Yeah.
And another breaking off that is context flow. Tools design that only returns, for example, an error, it's the output, it's good. And you can
Yeah, exactly. Yeah, context is a huge part. And I'm actually not going to talk a ton about context today, but it absolutely is, it could be its own presentation, because context is so important in this age of AI and agents. Great. So let's go ahead and crack on with the demo. So I'm going to show everyone how it works, and we're going to walk through it together. So let's see if I can go ahead. Oh. I have the code base already open here. I'm going to I don't have Docker running myself, so I'm going to go ahead and start Docker up. And I'm going to just showcase it first, and then we'll get into some of the specifics of how the Docker is working.
Should we be running this at the same time as you, or are we going to come back around?
We're going to come back around. So if everyone just wants to take a look at what we're going to be building, I would start there. Let's see here. We'll go into our front end. Here we go. I just forget the port I used. Okay, so here we go. Let's make that bigger. All right, so pretty basic, right? So if you look up here in the top left, we just have 3 text fields. You can put in some dummy data, whatever the heck you want, and then checkout. If we take a look here, we can just click. This is running a simple endpoint in the back end, processing our data, right, with a whole bunch of crazy functions, and then returning a response. And then in the top right, we see our live metrics. So this is actually tracking our backend. You can see our error rate, our latency, our memory usage, and then our DB connections. Not really important for this, but and then in the bottom left here, we have our failure mode, which we can inject. So obviously we have our 3 that we talked about, and then we have our logs. So before I input the error mode, I'm going to jump back to our and get our agent set up. So I have our agent running on a different port. This is what our agent looks like. I gave it a front end so it can actually look the part, right? And as you can see, it's updating every 30 seconds. So it's pulling the logs, POLL, pulling the logs every 30 seconds. And then it's measuring it against our thresholds that we talked about earlier. And you can see the different thresholds are set up right here. And they'll highlight when it triggers. So if we jump back to our little, shopping cart, let's inject a memory leak. And we'll inject the failure. And now as we start to, you can see it's starting to get kind of slow. It's getting kind of buggy. If we jump back to our agent in about 2 seconds here. Oh, triggered the latency. And you can already see it's off to the races here. Can people see this? Let's make it bigger. How's that? Is that better? All right, so let's start here at the top, because it's already working hard. So you can see the first thing it did was just to get the metrics. And so you can see the results there. It's just some basics. The next, it got the health, ran the health tool call. Everything's looking good. Even though it says memory leak, I have that removed for the agent so it can't cheat. The tool call, then the get recent logs tool call gets fired. So now it's taking a look, right? See what happened. It's looking for any warnings in the search logs. It's going to go ahead and read the source code. So it's like using every tool in its box, right? And then it gives us an incident report. So it says the service is experiencing high latency of 700 milliseconds, exceeding the threshold. Root cause. It gives us a little root cause analysis there. Recommended actions. Let's go there. So assess and understand the memory leak. We analyze why memory is not being released in the service. Implement checks. Review service flags. Consider refactoring. It looks like it found the actual cheat code line in the code where we are actually adding in the latency delay. So it's pretty smart. I figured that out. So you get the idea, right? And so just like that, it's basically done the work of an on-call engineer, in the sense that it has kicked up at 3 a.m. when someone would have to get dragged out of bed, right? And then done a report, and then given us, we could send that to the engineer's inbox and just have them read an email instead of getting online and trying to figure this out themselves, right? Yeah.
Is there a way to protect against hallucination that may make up its own reason why things are happening?
Yeah, absolutely. So this is absolutely a concern. Hallucinations. How do we protect against them? And I'll talk a little bit about this at the end, but you have to just be ready for if hallucinations happen, right? Which is, I think, another reason why it's important not to just give it full reign access to edit your code base and just repush. Is because ideally it does all the hard, heavy lifting, but then checks with humans in the loop, right? So that way a human can say, oh yeah, it just hallucinated that we have this random line in the code, wasn't anywhere there. And now we're going to create this huge problem by trying to, fix our app. And so there's no perfect science to it, but there are ways that we can include humans, or include system prompts to help the agent be a little bit more cautious. And then also obviously have humans to check its work. But a very valid concern. I mean, we want to make sure that we don't just push an update to our app without it first being checked, right? That's an important part of the loop. So you can see here, I won't, I'll maybe show one more. So let's go ahead and reset to nothing. We'll check out again. Things are going back down to normal. We'll reset the stats. Now let's do a payment outage. So here, if we start to check out, I didn't inject. So here, if we start to check out, you can see stalls for about a second and then throws our 500 level error. If we jump back over to our incident, okay, it looks like it recovered from the last one. Let's see if I can just automatically trigger it. I need to wait 30 seconds. We'll add a few more. Yeah, go ahead.
Why is the error rate jump around in the lag metrics? Is that a response to the percent of payments that fail or something different?
Yeah, sometimes it does a retry. So it might retry and then count those as successful attempts. I don't know. But the way that you measure the way that you measure errors is maybe is different for each application. Let's see if it's run. Oh yeah, here we go. Error rate's greater than 10%. It's already got it. It's doing the same stuff, right? Getting the recent logs, getting the health, checking the metrics. Let's see what it says. Experiencing a significantly high error rate. Payment provider is unavailable. Recommended actions: investigate the status of a payment provider and restore connectivity if possible. Check if there are any known issues or outages reported by the payment provider. That's a great recommendation. And then set up alerts. I also think that's a great recommendation. So you get the idea. And this agent is obviously sitting kind of in a third party, right? So it's sitting away from the stack and it's just looking at the different endpoints that we give it in the backend. And so with a couple of tweaks, you can easily take this same idea and just apply it to your code base, right? I mean, there's not there's not a whole lot of lift there to just apply this same agent to many different code bases, which I think is one of the reasons why it's valuable and why I wanted to talk about it today. Are there any other questions about the general setup of this demo or the
So what, sorry,
go ahead, yeah.
inject error doesn't edit the code, and is it actually editing the code in the back end to inject it, or when you switch the drop down away, the bug goes away?
Yeah, so it basically is just routing the traffic through a slightly like malformed function. So yeah, instead of just processing it normally, it's that, if the error is set to a certain thing, it'll pass it through a separate function, which is where the error actually lives, and process it there, and then continually pass it forward. And then if, obviously if we have an error set, an error mode set, it'll trigger in that specific function that we have set. And you can take a look at it in the code as well. If anyone wants to jump in, let me just pull that up really quick. If people want to jump in, all of the details about how the backend is set up is just in the main.py file under the backend directory. So you can absolutely see how it's set up and how the backend is working currently. And then we're going to be getting into the agent code here in a second, and we'll talk through some of that. Really quick, let me just jump back to the slides.
Simplistic question: is the log data source, the log that's reading, is that a format that you define, or
Yeah. So, and we'll talk about this when we look at the code, but we're essentially mounting a log file to the Docker instance. So that way the agent can then read the log file from the backend. It's just a classic like app.log. Anything from the consoles just get thrown into there. And so it's using that. But it brings up a great point. And it kind of broke my brain when I first thought about this. But you can really set up, the get logs, even though it seems simple. You can set it up to look at an endpoint. You can set it up to get a file from an S3 bucket. You can set it up like we have to where it just mounts to the Docker instance and look at the mounted file. I mean, there's infinity ways to set that up. And I think it brings up a great point. Like you can do it in many different ways. And so, yeah. So a little post-demo debrief. Let's talk about how the tools actually look in code, because this also broke my brain when I first was learning about it. Let's take this calculator tool. So first, a little bit of I just want to pause for a second. So LLMs are very probabilistic, right? Their job is to predict tokens. And so they train on all this data on the web. They see different examples of math or whatever, and then they try to predict. So when you say, chat, what is 1 + 1? It knows the answers to because it's seen that problem before, probably 100 times or a million times on the web. And that's why it's good at it, is because it's seen it before. It's in the training set, right? But if you try to do something like, chat, what is 4,697 times 100 million, and you go to these crazy big numbers, it's going to have zero clue. It's going to hallucinate a whole bunch of numbers because it just doesn't know, right? And that's just because it's trying to predict what it would be. It doesn't actually do the math. And so if you have a tool, right, something as simple as this, right, you have a tool that passes in 3 arguments, 2 integers, and then a mathematical operation. And the agent can then choose what 2 numbers get passed in and what the mathematical operation is. All of a sudden, you've just unlocked all of arithmetic for the agent, right? The agent can just decide what 2 numbers it needs and then pass them into the tool, get the response, and then inject that into its output. And the first LLMs were not doing this, and so that's why they were so bad at math. But now I think Gemini and a lot of the frontier models, they're doing this in the back end, right? This is how they work. And so, it's really just pretty simple, right? Simple math, simple Python functions, but it unlocks the world for an LLM because it just doesn't have that capability built in. Again, so tools are so powerful. Once you have your tool defined, you can then put it into a JSON aggregation snippet. We'll call it something like that. But essentially, you're just attaching the name, description, and some properties about the arguments that it takes in to a JSON. We'll go back there, then we'll come up here.
So with tools like a calculator seems relatively straightforward, but if you, I don't know, incident management or debugging kind of workflow. When you're trying to implement or get to leverage like a more complex tool, have you run into issues with like memory usage or token burning, and like how do you work through those or more complex tools that you want to have access to?
Right. So the tool, so the tool itself isn't actually using any tokens, but what you return to the tool, what you return from the tool to the LLM is using tokens. So, you could do a lot of work inside the function where it's not actually doing any token usage and then just return the answer. And then you've basically solved your problem, right? Where you're just using very few tokens and you're having Python actually do the majority of your work. Yeah, that's a great question though. And something to think about, right? If I just paste like the whole log file into our output, we're absolutely going to chew through a lot of tokens. And so you just want to be careful, right? That's why I did the get most recent 25 logs, so you don't just return the whole log file and all of a sudden you're like $100 in the hole with Claude or whatever. So yeah, and then go ahead.
Could the tool of an agent in and of itself be another agent that's returning some sort of other data from another source?
Absolutely. Yes. So that's very meta, but also a great example of like how some of the best models are working today. So that's where subagents come into play, right? So Claude Code is like an agentic harness. Claude Code spins up 3 or 4 different sub agents that then go take care of its different tasks. And sometimes you see that when you use Claude or one of those frontier models. But that is 100% how a lot of the like top models today are like using their agents and their sub agents in that way. So yeah, great question. Great question. Any other questions before we keep going? So this kind of speaks for itself, right? Search logs. We're just defining it in the JSON. And this is just to basically bring together all the tools we have and put it into a computer readable way, right? It's pretty straightforward. And then we have our agentic loop. So I have it listed here as state, but state really just represents all the context, all of the different results from the previous tool calls, what we know so far. It's our current knowledge standing with the model, right? So we're going to do a loop. In this case, we have a max, we put a ceiling on the maximum number of steps. We don't want to just keep reading logs for, the whole day and then chew through like $300 worth of tokens. We want to maybe just truncate it and say, okay, don't go above 10 steps. So that way it keeps it more concise and you don't, and maybe it could even just spin up another agent if it needs to dig deeper. You could architect a few different agents in that way. So you have a loop through the max steps. We get the result from the LLM just by passing in the current state, which again is our context, all the relevant information that we want our LLM to know. If the LLM returns done, then we're done. We break the loop and we present our output. Otherwise, we want to set up our outputs list and go through all the different tool calls the LLM needs and aggregate the responses and then feed it back to the LLM and create a new state. Yeah, go ahead.
Sorry, it's too pedantic.
No.
What's defined as done here? Like, can you customize that in any way? Like, depending on what kind of thing you're asking it to do, like, you're not done until I get this kind of result.
Absolutely. So we'll see the definition of something like that in the system prompt. So, and we'll look at that together later, but you absolutely should define that, right? The more specific you are with the criteria for how good done is or what done means, the better the model will actually perform your task because you've been explicit about that. Yeah. Go ahead.
And we're not just running through our entire list of tools exhaustively and running each one every loop. The LLM is deciding, I think I need to run the following 3. And then we're just running those 3.
Exactly. Okay. Yeah. Yep. The tool calls are coming from the result, which comes from the LLM telling us what work still needs to be done. And we're not looping over like our whole exhaustive set. Absolutely. So again, like when you break it down to this level, it's not actually a ton of code that you need to create an agent, right? I mean, like the LLM's doing the heavy lifting for you in the back. And then if you're just careful about how you design your tools, it doesn't really take that much. This makes it totally like in scope. I felt like the first time I kind of really walked through this, it really broke it down for me. And I was like, wow, there's so much I could do with just like 3 snippets of code. It's really simple. So let's get into the code. Let's actually look at what's behind the scenes of this agent and do it together. So I was previously gonna walk through the code and then have everyone do it, but I think I'm just gonna have all of us do it as we walk through it. So I think that'll make more sense. Okay, so if everyone opens up their repo, I'm gonna first just start in this docker compose.yaml. So for just a quick summary, if you haven't used Docker before, it's just a way to basically encapsulate if you have different services you want to run with different dependencies. It's a way to put it all together in one like nice wrapped present with a bow, so you can just start it and let it do its thing, and you don't have to worry about virtual environment or starting 3 different terminals for the different services we want to run. And so our Docker compose.yaml is a way for us to just bring all of that together. So I want to make a couple of notes here. So first of all, as you can see here, when we're building the backend, we are mounting the logs volume to the Docker instance. So this is what we were talking about earlier. This is a way for us to actually bring the file, the log file, up into the Docker instance, so that way our agent can then use it. Again, this could be done in a million different ways. You could just have it be an endpoint or something different, but this is how we're choosing to do it. And I think it's just important to make the connection of we need to give our agent the logs. So how are we going to do that? That's really the question you have to ask yourself anytime you want to give your agent access to anything.
That's right. That's why you're using Docker compose, right? So you can bring up one of these, and attach a part of him to him.
Exactly.
Snap the link under the table of these 2 file systems.
Yeah, an easy way for us to do it locally. And so then obviously we run the back end. We do a simple run on the front end, and then we have some different things here. So we have the log file. This is our agent, by the way. We have our agent log file. Again, we have 2 volumes. We have one for the logs and one for the source code. And we're mounting those just like we discussed. We're also going to define some environment variables here for the log file, for the source file, so we can just access those in our agent code. And then we're pulling in our Anthropic, OpenAI, or Google API keys. Now is a great time for me to just mention, so in your code, you should see this .env.example. You can rename this to .env and take off the .example, and this will become your environment variable. And then you can just uncomment one of those API keys and then paste in your actual key, and then you should be good to go. It'll automatically pick up whichever one you put in and then use it. I have my .env here. I'm not going to show it because I don't want $1,000 or $100 million worth of usage on my account later this evening. So that's how you get it set up for when you actually want to run this. Okay, and then in the agent folder, we have a main.py and then a main_empty. So the main_empty just has like 3 or 4 sections that have been removed for us to go through together. So you can at any time just take a look at the main.py and see what's actually happening and then compare and then fill it in if you want. But this is a way for us to just do it together and actually learn without giving away the answers. Does everyone have this pulled up? Does everyone have this ready to go? I'm going to go ahead and just get started. If you get behind, yeah, go ahead.
So I see that in source, you said on it might have services.
That is a great question. Absolutely. So this is kind of getting back to the logs question. You could mount them all individually. You could mount like a directory. You could also come up with a unique way to do it. If you really have a large code base, you probably don't want to maybe mount it all, but maybe you have it in GitHub and you can have the agent look at GitHub. Maybe you have it, all in an S3 bucket somewhere, and you can just give it access to pull, or it really becomes the question for an AI engineer to figure out, okay, how are we going to get all this, this big bucket of materials to our agent in a way that's not going to charge us tons of tokens, but it's also going to be quick. It's a great question and one that we have to think about if we're building something bigger. Obviously, for this, it's just one file. It's really easy for us to just mount it, but it's a great question. Great question. So let's go ahead and get started. So if you scroll down with me, we'll just start taking a look at some of this stuff that's going on. So we have our imports, right? Nothing crazy. We're pulling all of our environmental variables from the Docker files. So we set those up, and I just displayed those, right? We have our source file, log file, our API keys, and we're pulling all of those from Docker. We set up a couple of data structures. If you notice here, I have this thing for mutating tools. So if we ever want to run the tool reset service, I have specifically made this so that way, if we have any other mutating tools, you just type them in here, and the code will make sure that you have a human in the loop approval before you do those tools. So I didn't really make a big deal about it, but there was a little button on the bottom right that said reset service, right? If the model ever recommends that, it'll just pull the button. You say like, okay, you got to reset the service. It can't come from me. It's got to come from you. This is, again, one of the ways that we can restrict our agent into not doing something that we're not expecting. We define our anomaly thresholds, right? So this is, again, specific to each app. And we can just set up an error rate or a latency threshold and then make adjustments here. We then get our LLM clients, depending on which API key you have set up. So, these are just coming straight from the frontier model documentation. You can find this just about anywhere. And all LLM models know how to use these now. So pretty simple and straightforward.
What are you giving?
So these are just the
Which one for three?
I'm specifically using OpenAI, just because I had it already set up and I have some funds in there. A quick note: this will probably use like maybe 10 cents of usage. It's not a lot, but just beware. You want to know what you're doing, right? So then we get into our tools. So I have left this one unfinished, but you can see like get metrics. This might look a little bit scary, but I promise it's not. We're just basically calling the backend URL with an HTTP request. We're using a get request, right, to get the metrics, and we're formatting it into a JSON. We're removing the cheat code, the failure mode, right? No cheat code for the model. And then we're returning it in a JSON string format. So that way the model can see the JSON version of what we just returned, right? So at its base, it's really not that crazy. Same thing, right? Search logs. We're using error handling, so it makes it look more convoluted. But again, if you just kind of start to look at it a little bit more, you realize it's not too bad. You open up the log file and you read all the lines, and then you just do matches, right? So if any of the matches from the log lines match the query, we want to keep them. Otherwise, we toss them. And then if the model has specified a level, then again, we just want to match the log level to the level that the model has input into the function. And then we just want to join them all together into a string and then return the top 20, which is what's happening right here, right? And then obviously it will return an error if a string error if something went wrong. In that case, the model will just handle the error on its own, right? Like it'll see, oh, there was an error. And so then it will say either, okay, I got to use my other tools and rely on those more, or it might tell you that, right? It might say, oh, I wasn't able to look at the logs. I can't actually know what's going on. Like you need to fix me first before I can fix the app. I think it's just good to internalize how this output is actually passing through the model and what the model does. I'll just scroll through some of these last ones. We won't spend a lot of time, but you can see, again, opening a log file, reading the log, returning it. The reset service. So this one's interesting. It's just calling a backend endpoint. So there's nothing crazy here, but in my code in the backend, I have an endpoint set up to reset the service. Not really the best decision, in my opinion, right? You don't ever want to expose an endpoint for resetting your service. For the sake of the demo, it's okay, and I think it proves a point. But I do not endorse putting an API endpoint to reset your entire application out there on the web, regardless of how secure it is with API keys and whatever.
And of course, if the app is hosed and is unresponsive, you can't even call the endpoint to ask it to please
Exactly, right?
You need a side channel.
Exactly. A great point. And so, and again, the get health looks very similar with just an HTTP request. So let's go scroll up. Let's do this read source file. So if everyone wants to scroll down with me, this is going to be pretty easy because we've just seen a lot of similar functions. So let's do this together. So we're going to start off by just doing a try except block. Exception. And my Copilot's helping me out here. I'm actually gonna snooze it because I don't know. Sometimes it's distracting for stuff like this. Let's do it for 20 minutes. All right. So on the chance that there's a problem with whatever it is we're doing, we do want to return something. You want to return an F string for the source file not found at, and then let's put in the source file, the directory or file path. Yeah, there we go. And then what we wanted to actually do inside of this little try except block, we want to go ahead and open up our source file. And then we're just going to return f.read. So I think it's important to note, so this is like, again, I kind of alluded to this earlier. We're literally just pasting in the entire main.py because it's not that big, right? But if you do have a huge, large code base, like you mentioned, you would want to be specific. Like maybe you ask the model to input a starting and ending line for it to actually just grab a certain snippet of your code. I don't know if you've ever noticed, Claude Code does this, right? It says read lines 1,300 to 1,500. And then it might read 1,500 to 1,004, like 570 to just get the last little bit. Like it can kind of just grab only enough that it needs. And so again, a tooling decision that can make a big impact. Go ahead.
It's the LLM figuring out which tools you need to use based on the situation, or you kind of have to tell it when to.
It's mostly figuring it out on its own. So obviously we're going to give it some system prompt. So at a high level, we want the agent to find problems like triage, to maybe make recommendations, and to actually implement fixes where possible. And we can tell the model to do that, so that way it has a general idea of the direction it needs to go. But then it'll look at our dictionary, our JSON full of tools, and it'll make decisions about what to actually call based off of what it has. And so it just looks in its toolkit, maybe picks up 3 tools, calls them all, looks at the output, and then decides what to do next.
You have to describe the tools to it, or just look at the code and figure out that this is it. This tool runs.
We describe it to it. So I don't know, right here. So here, it's actually looking at the description. Like it's looking at the description. Some models work by you just give it the function and then it looks at like the doc string. Same idea, right? You're looking at the description, what type of inputs it takes, and this is how it actually learns what it has access to and what it's capable of. And so that's why this step is so important, is because if you don't do this or you're not descriptive here, it's just going to kind of wallow. It's not going to know what this does, and so it might try to use it, but it might not. Yeah.
Where to JSON
Yeah, no, so that's actually a great segue. If everyone wants to jump back to the code, we're going to scroll down. It's actually right here. So it's just below all of our tool calls. Yeah. So we have our tool handlers. This is where we just attach the function name to a string function name. So this is just like, get metrics, the string is getting mapped to our get metrics function. This is all that's happening here, right? So we're just making a connection from the name to the actual function. And then down here is the secret sauce, right? This is where we actually tell the model, all right, here are the tools you have. Here's what they do. Here's what their inputs are. Here's what they return, right? So as you can see here, we have get metrics. The description is fetch live service metrics, error rate, latency, memory usage, DB connections, request count, error count, uptime seconds. So that way it knows what's coming in the payload response, right? And it's just a simple way for it to like, oh, I need that information. Let me go get it with this tool. And then the input schema, there's nothing needed, right? There's no like input parameters or anything. So it doesn't actually need to do anything other than just make the call. If we scroll down to something like search logs, you can see that the input schema gets a little bit messier because you need to be more specific about what can actually go in. So, we have a description there, but then we have our input schema. It's looking for an object with parameters query and level, right? Query is a string, and here's a description about it. Here's what it needs to be. And then we have our level. Level gets even more specific because it's a string, but it needs to be one of these three things, right? Warning, error, or info. Because if you don't be specific like that, it might just try to look for, like, I don't know, debug. Debug's a common log level, but if that's not in our application, then all of a sudden it's going to be looking for something that doesn't exist. And it's going to give an all clear because there's no logs that, and it gets messed up. So we have to be careful here to make sure that we're putting in the right things. And then we give a description. And then we also put required. So this is telling the model, okay, we need query, like we need an actual query to use this, but we don't need a log level. So again, this is like the typical stuff. When you like look at a function and you see a doc string, or you can take a look at a Python function, and you just visually see the elements that tell you that there's a default value or there's not. Like we're basically just defining that in a computer readable way, so that way the model can just automatically know what's going on. Any questions about this?
Input schema, is the format of that? Does it have to be specific to the library? Like type object, like what are all the different parts?
Yeah. So I'm not gonna lie, I don't know a ton about the specifics there. I'm sure like if you were to go to OpenAI's documentation website, they'd have it all listed out. If I'm being honest, I don't think I've ever not seen object. So I'd actually be curious myself. But I think it is dependent a little bit on the language that you're using and the different types of functions you're trying to put in as tools. But I actually don't know if I have a concrete answer for you on that one. Any other questions? Go ahead.
Very similar vein. You may have touched on this already. Seems like Anthropic and OpenAI have been a lot of standardization around like markdown files and stuff that you use to kind of guide creation. Is that the same case for tool files? So like kind of a standard that's more or less portable.
Yeah, and actually, this is a great segue. Let me just scroll. If I just scroll down to the bottom here, we'll come back. But you can see that like Claude uses the format that we've been describing, but then OpenAI uses something similar, right? Its type is actually a function. And we're then just like porting the different things to a slightly different format. I mean, mostly it's the same, and obviously, like in like what is that? 8 lines, you can transfer the two.
Yeah.
So, but it's a great point. Yeah. Yeah. It is like the same general format, right? Name, description, tool, inputs. Just the structure is like kind of slightly different.
As I say, to just add that you're actually pretty like skills. This is a PTM stuff. So what
Oh,
you said,
okay.
yeah. In fact, for Gemini, it seems that the Gemini provider in the code is using the OpenAI API.
Yeah.
And I understand that as well.
Yeah, exactly. Yeah. And I did that to make it like super simple for us to use. And that way there's not like, tons of code, but absolutely. I mean, they're all kind of right in the ballpark, right? So let's go ahead and build one of these. So if you scroll up here, here's a to-do for us here. Everyone wants to get to that point in their code. We're going to be doing it for read source file, which this shouldn't be too bad because read source file is pasting in the whole chunk of text. There's no input parameters, but we can go ahead and we'll just go ahead and make ourselves a new little JSON block. We're going to start with its name. We're going to map that to the name we had above, read source file. Now let's get into our description. And then let's give a description. So, if we just think about um, the function, we can probably say something like read the backend source code main.py to inspect the implementation and identify the root cause of code bugs. Something like that. I mean, honestly, as long as you're giving a decent description, the model's pretty smart, but we'll just say something like that. And then we'll go to the next line. We'll just do, oh, did I forget a comma? Sure did. Don't forget the commas. And then we'll do an input schema. And then we're actually going to do a dictionary here. We'll do type, object. And then we'll do properties, empty, because we're not actually passing in any parameters for the input schema. And I believe we should be good to go. Pretty simple. I'll give everyone maybe like 15 seconds if you want to finish typing yourself. Any additional questions about anything we've talked to up to this point?
So the LLM that you choose has to be one that supports some issues. It's not just any. You can just put any LLM in there.
Yeah, yeah, I'm gonna say yes. Frontier models are like built just like this, right? I mean, like you can pass in a list of tools and it's all good. You can set up agents with models that are like smaller. Like if you had like a Quen or Llama, you could build yourself an agent, but you'd have to just be a lot more explicit to the agent about like, if you want to use this tool, you have to use this word, and then you have to, do like an if then, if this word, then call tool. It's not quite as like simple and easy. But you absolutely can use a smaller model. It just, again, takes more time to like code it up and be more verbose in your code with how to route everything. I mean, that's really what most of this is just routing, right? You want to route the LLM to the right tools and back, and yeah. But yeah, great question. Okay, so we've already taken a look at this, the routing to OpenAI tools. If we scroll a little bit further, we now get to the system prompt, which people have different opinions on how long or how verbose or how wordy you want your system prompt to be. My thought is, as long as it's not like over 2 pages or whatever, like as long as you're keeping it kind of to the point, you should be really instructive, and spend time making it really instructive. So I've added a little to do for us here. I think we could maybe just add 1 or 2 lines together. I'd say we add an investigation strategy. So we'll just say investigation strategy. Say 1, check health and metrics to understand current state. Now we'll give it somewhere to start. Next, we'll search logs for errors, warnings, patterns related to the anomaly. So that way it has some type of direction, right? Maybe we should start with the logs. As I'm creating this, I also just kind of think about like, what would I do? Like if I was an on-call engineer at 3 a.m. in the morning working for AWS, what would I want to do? I'd want to crack open the logs, right? Take a look at it myself, and then maybe investigate some part of the code. And you can just map that same type of flow into your agent, right? That's exactly what we want. So then, part 3, read source code when logs suggest a code level issue, such as exceptions, tracebacks. Okay, and then we'll do 1 more, and then we'll just say something to wrap it up, right? Correlate findings remediation steps. And then, like we could even put something here, send an email. Something like that, right? You could like put instructions like that into your agent, and your agent will just try to find the tool that best fits that. Obviously, we don't have a tool for that, so it's not going to really know what to do. But you could absolutely set up a tool to send an email or a message or something. So just for show, I actually don't want anything in my inbox, so I'm gonna get rid of that. Any questions about the system prompt? If you want to take a look at some of the other things that I put in here, I'm specific about how I want the code fixes, right? If there's a code fix, I want it to give it to me in code, not just kind of like describe it, because I like to view the diff or like what I should actually fix. And then the incident report I set up in a structured way, so that way the markdown looks and feels the same every single time. And again, you can be as verbose and wordy, or you can be as to the point as you'd like here. That's just kind of personal preference and what gets the job done. But do people have questions about the system prompt? I don't feel like it's too crazy, right? I mean, just giving it instructions, right?
The system prompt actually send it every message, right? Or is it like from the beginning?
I'm actually not 100% sure. I mean, typically you for sure send on the first one, and then typically you include some kind of version of it in each subsequent call. Because I can't remember. The reason why I hesitate is because some models will remember that kind of thing. And you can just pass it through to your client at the beginning. Whereas some models, like especially the like earlier ones like Quen or Llama, like they don't have any of that built in, and so you just have to remind it what it's doing every single time. And so that gets more into the context management side of it, which which there's a lot to unpack there. But yeah, absolutely something to make sure that it's happening in the right way. Like you want to make sure that it's getting the instructions and it knows what to do at every step. So whether you pass in the system prompt or some version of the system prompt, that's really important. Right. Yeah, go ahead. Yeah.
Curious that if it's has instructions to do something that the tool isn't data for it, is everything just going to crash, or is it going to keep on looping forever? Or...
Yeah, I mean, it obviously can't. Like if I were told it to send me an email and there's actually no function to send an email, it's not going to be able to. And so it might say, I don't have the tools to do that. Or it might try to hallucinate in your system output. You might actually see like an email to Nathan randomly pop up, and you're like, what the, like, I thought this was supposed to send, like I wasn't wanting this in like the report. And so you'll see different behaviors like that depending on what type of model you're using. And so you just want to kind of think through that. Or you can even put instructions in your system prompt and say, if you don't have the right tooling, just say so, and explain why or something. But yeah, great question. Okay, if there's no other questions, we'll keep going. I believe there's just a few more things to look at. I think we're going to take a look at the agentic loop. So here are some data classes. These are really simple, right? We have one defined for a tool call, right? So we give it an ID, a name, and an input for a tool call. This is just a way for us to keep track of the information that we're passing through to our tools. We also have a data class for a turn result. This is the little Boolean for done we saw earlier. This is what gets flipped if the model's done. We have the thinking, the text, the tool calls. All of these are what we use in our agentic front end to see what the model's actually up to. And then I'm actually going to kind of skim this. This is a Claude session. So I have one for Claude. I also have one for OpenAI. They're right here back to back. You can add, we can add the user text to our messages. We can add the tool results to our messages. And then this is where the actual LM call gets made, right? We're using a Claude Haiku, super cheap. And then we're attaching the system prompt, the tools, and the messages, and then we're letting it run. As you can see down here, we basically just pull it up. I mean, Claude makes it, or Claude, OpenAI, and Gemini all make it really easy to pull these insights out of the LLM response, right? As you can see here for thinking, we're really just getting all the thinking, labeled information out of the response. If you were to use a model like Llama or one of those other ones, you would need to be explicit about how you structure that in your output. And, and your system prompt might be much more verbose explaining that. And, maybe start your thinking with a, thinking tag, and that way you can actually like parse it out. But these models do it for us. And so it's really easy just to grab like the text and the tool calls and everything. We put the tool calls into a tool call data structure, same thing with the turn result, and then we return it, right? So this is like part of the LLM and how like, you're setting the engine up. And then we have something very similar for OpenAI. Just completing the response using, I believe the model is 4.0 mini. It has a little bit more code to handle the tool calls. This is just frontier model specific. And then some helper functions. I do want to get to this agentic loop because I think it's important. So this is just checking to see which, if you have one of the clients set up, we want to make sure we use the right client and not just use one that doesn't exist. So that's what this is basically doing, right? Checking the API key and making sure, we're using the right thing. We are now at the point where we are starting the investigation, right? To make it easy, I did already include the loop, right? So we're looping through right here. As you can see, if the model is thinking, we want to display the thinking. If it's done, we want to break the loop. This is all very similar to what we were looking at in the slide, right? It's not too crazy. And then here we have our tool calls, right? If it's in the mutating tools dictionary that we defined earlier, we want to get human in the loop. And so we want to go ahead and get that approval. Otherwise, you can just go ahead and handle it. But before we get too far into that, I do want to just come back up here. We'll do this little part right before the loop. Okay. So, I actually think this is really simple. We're basically just calling this prompt.add user text alert. And I think I ended up leaving most of the loop, so that way it wasn't too complex. Does anyone have any questions about the specific implementation of the loop? I feel like it's not too bad. It's very similar to what we were looking at earlier in the slides. So if that's making sense, this isn't too much different. Yeah, so for our specific use case, I just didn't want to do more than 10 calls. If I'm being honest, that was kind of bad coding. It should have just been, in range to 10. But I just didn't want it to go on forever. The number that you actually choose for your own implementation depends on how much you want the model to kind of be able to act on its own before you cut it off and say, you're done. So I chose 10 just to make sure we don't use too much money and usage and tokens. Cloud Code probably has like 1,000 or something really big, so that way it can like do lots and lots of steps. But yeah, that's a design decision for each app.
I'm sure, there's also another way to do this via the Pod SDK.
Mhm.
And I don't know if this uses the SDK, but
I don't think it does.
okay,
I was mostly
very similar.
Yeah.
I think a lot of the steps are very similar.
Yeah. I'm sure it's probably pretty nice with the SDK.
Yeah. It's more, I guess there's an Anthropic one, but this is more general, I guess. You kind of have the same concepts, similar concepts for OpenAI and Anthropic, right? Define it all different variables and you call the right thing.
Yeah.
But I think the Anthropic SDK is a little more Anthropic. But I was curious, like in the code, you actually have thinking set to none for OpenAI. I was like, maybe they don't need maybe it's rolled into the same.
Yeah, I can't remember why I did that actually. I feel like it was because of some type of like it was already rolled into the output or something, and
Yeah. Which I don't have to provide I guess, yeah, that's another question I had is like, every time you do complete, you pass the entire message array.
Yeah.
Because you keep appending things in
Right.
complete function. So every turn you're building the whole array again and passing it again.
Yeah.
The API is stateless, right?
Yeah, I think it's stateless, and so we probably could and should use some type of like context management system. Because like it's just building the same thing every time. Like
API on the API side, if I'm not mistaken, it caches it. Is you have this. So otherwise, like every turn, you're gonna exponential keep passing the same thing again and again.
Yeah.
Because there's no other way for them to make it stateless. The API is stateless. There's no cookie or anything.
Oh, really? Okay.
So it's completely stateless. All the APIs pass everything.
Yeah, that's kind of interesting. I wouldn't have guessed.
Yeah.
I kind of I would have thought they would have passed it like that.
Public proxy server. So I know for a fact that it's stateless.
It's stateless. Okay, yeah. There you go. Cool.
It's an HTTP post request. But the drawback is, I guess, like you have to keep passing the whole array every time, and giant.
Yeah, I get super.
So it hits the network. I don't think it hits the token cost though, because we have these things on caching.
Yeah.
And so there's there's all these nuances, but yeah, sorry for my questions.
No,
Maybe
it's good. Yeah, no, that's great. All right, you guys, we'll take another like 30 seconds. Go ahead and come back in. I just have a couple of takeaways that I think are valuable, and then we'll wrap it up. It is time for lunch, so I'm trying to get us out of here too. So I just have a couple of takeaways, and I'm going to kind of breeze through these because we've talked a lot about them already. But I think the difference between tools. Oh, yeah.
Ladies and gentlemen, the demonstration is continued. If you could please keep side conversations to a minimum. Thank you.
Thanks, everyone. So the read tools and the mutating tools is something we've already talked about. But again, you want to make sure that you're careful here. We kind of touched on this as well, but other mutating tools might look like creating a pull request, updating the code base directly. And so you want to make sure you handle those properly. Another little note, so I'm going to be 100% transparent here. I actually have not used a lot of these like enterprise grade solutions that do something kind of similar, right? There are options to buy instead of just building yourself. Obviously, that's not what this tutorial is about. I think I'm kind of always a proponent of build yourself so you understand. But if you're in an enterprise right now and you need a solution, like you could absolutely consider one of these to look into or potentially explore some more. Again, I haven't used them myself, so I can't speak to them, but just something to keep in mind. And then I also just want to touch on Claude. So, go ahead. Yeah, go ahead. Snap a picture if you want. I also just want to touch on Claude. So Claude can kind of do something similar, right? Claude already has a lot of these like coding tools built in, right? You can have it look through your code and you can give it some instructions. It's definitely not as tailored to our specific use case of investigating your live application, right? But you could probably figure out a way to do it, and just directly with Claude or Claude Code. It's something to think about, right? There's always these like different levels of how much should I build, how much should I buy, and somewhere in the middle is usually where most people fall. So just to call out, Claude can do a lot of this stuff, and it's important to consider, what they can do and if it's worth the cost and everything. But just wanted to throw that out there. And then a last set of takeaways. Again, I just want to highlight again that the tools are the key. I mean, really, that's what makes Claude Code and some of these like, billion-dollar tools so valuable. It's just their simple use of tools. I think most of but Claude Code actually got leaked not too long ago, and it exposed it to the world, and everyone was like taking looks, right? And I remember just thinking, wow, this is like really lightweight. It's not a crazy code. It's not some secret crazy sauce. It's just some simple scaffolding to really hone in the model to do what you need. So just an interesting thought there. Again, I want to highlight the permissions because I don't want people to be using agents without thinking through permissions first. There's always horror stories on the internet right now about OpenClaw deleting their whole inbox, or OpenClaw, hitting them with the remove dash RF, on their whole file system. You don't want that to be you. And so keep in mind the principle of least privilege. Only give the model exactly what it needs to accomplish its task and nothing more. And you'll be hopefully in a much better spot than those guys that lost their whole computer. The agent typically acts, in your behalf, and it acts in your best interest. Most of the time when you're talking with an agent, you kind of feel like it's on your side. And I think for the most part it is, but there are many times where it might hallucinate and start to think that something is going to be a great idea when it's actually not, right? Like maybe it thinks that resetting the service and deleting your whole SQL database is the right move, and that's actually not the right move. That will make it fast, but we don't want it to be that fast. And so you just need to keep that in mind and use humans in the loop where necessary to ensure that you're, again, just safe from the intent of your model. And then lastly, I think it's important just to think that yes, agents are powerful, and yes, we should use them often, but no, we don't need to use them all the time. Like I recently for my job created a simple service that it's a cron service. Every morning at 7 a.m. it like pulls some APIs from a news feed. And then it doesn't even summarize or anything. It just gives me like the top 5 articles that are relevant to me based off of a word search. No agents, no AI, no nothing. But when I showed it to my boss, he was like, "Oh, great, a news agent." And I was like, "No, it's not an agent. This is just a cron job. Like it's just a function." But like to him, that was agentic. And I'm sure that if he were like trying to build that, he would immediately say, "Oh yeah, we need an agent for this." And I would argue, no, you don't need an agent for that. Like that's something simple. And it gets into this idea of, this function that I had created was deterministic. It would give me the top 5 articles every day without fail. There's no hallucinations. There's no probabilities involved. It's Python, right? It's going to run. Probabilities start to get into play when you use these models, right? And the probabilistic nature, and like, yes, they're probably going to give you the right response, but they might not, or they might give you something weird, or, and so you just don't want to over engineer a solution that can be built with something as simple as a cron job or a function. So just keep that in mind, right? I think we have a habit of over engineering because of how powerful the agents are these days. And so don't do that. And honestly, that concludes the presentation. Thank you guys all so much. Yeah, we have a question.
For an observation, sorry, you can take it or leave it, but be careful not to bias your agent within your prompting. A couple of I ran with the bias detection on the prompt. And at one point, I think the tool called for the source file, it kept looking for coding bias. The agents have a tendency to latch on to those statements and may influence the output. So something like pick up all everyone's here. Something pointed out. Very easy to think you're putting something that is useful, but it goes and does it's probably much larger scale project. It could false latch on with it. It's rarely giving ground.
Yeah, absolutely. 100%. If you keep enforcing to the model that there's a bug in the code, we got to fix it, and there's actually not a bug in the code, it's probably going to try to fix something that doesn't exist. You're absolutely right. So avoiding those biases is 100% a priority. And that kind of gets into the system prompting and system engineering side of things. That's a great remark, though. Something to keep in mind that I didn't really think about when I was building this, but
The other thing was that binary yes, no, maybe a certainty score might be used there.
yeah, it's a great idea. Yeah, it's great.
I'm just kind of going off for that. I haven't implemented them, but I just make other people talk like my company about like I call it bot like mode, where you have a bot that's doing something, and then you have another agent and you're like, oh no, this like that agent's purpose, that second agent's purpose is to basically evaluate the first one. And so maybe in this scenario, you have an agent that's like looking for bugs, and then you have another one that's kind of like, okay, is this worth flagging to like
Yeah, absolutely. This is kind of like a, discriminator or critic setup where you have a model and we can even set it up where we give the report to our critic. We say, all right, like poke holes in this plan. Like, is this actually what we should be doing? And then you have it be, the devil's advocate. It's a great idea. And it's a way to combat some of this bias. Yeah. Any other questions before we head to lunch? All right. Thank you guys so much.